A fundamental problem in modern-day neuroscience is interfacing electrical technologies to neurons. Imagine that instead of implanting rigid electrodes into the brain, we could grow soft electrodes that are brain-like, tissue-like, and are grown by using the brain's own chemistry. That is exactly what that is Jianguo Mei's lab in the James and Margaret Tarpo Department of Chemistry, and my lab, the Nano Neurotechnology Lab, here in the Weldon School of Biomedical Engineering, were able to achieve. Spearheaded by first authors Sanket Samal and Shulan Zhao, we were able to demonstrate not only tissue-like growth of these electronic materials, but also the ability to control neural activity using the brain's naturally formed hemoproteins, specifically hemoglobin, to catalyze the growth of a novel polymer called NPBDF that is air stable and can be grown in solution. There are two fundamental challenges that we were able to overcome with this material. The first being that conventional electrodes form a lot of glial scarring when implanted. They move tissue around and they drift. With this technology, not only were we able to grow it inside the brain, we figured and we showed that it actually forms a little mesh tissue-like network around neurons. It just doesn't sit there. What we also showed is that this material has an intrinsic effect on the channel excitability in the brain. And when presented with NIR 2-photon excitation, exploiting a property of the material, both photothermal and photoionic, we were able to control and modulate neurons with millisecond precision and with power levels that are some of the lowest reported to date. It's not about implanting electronics. We want to move towards growing electronics inside the brain that is tissue-like, with the ability to kind of create novel materials and use intrinsic endogenous catalysts, specifically blood-derived proteins, to help grow these materials across neurons. We believe that we will reach a stage where we form living electronics inside the brain. The applications are multifold, not just in primary basic neuroscience, but also across the field spanning all the way from epilepsy to Parkinson's disease.